Okay, here's a solution to the race and how fast question. Clearly, the cheetah won the race to 100 meters. Then the kangaroo came second, and then the human came third. Also, clearly, to answer part B, clearly you can see that if we're going to rank the lines in order of steepness, the cheetah has the steepest line, the kangaroo is second steepest, and then the human was third steepest, which gives us this relationship between the steepness of a line and kind of how fast something goes. Okay, so when we talk about steepness of a line, we are already talking about the slope of a line. So in this section, we're trying to relate that the slope of a line is the same as its rate of change. So for answer part C, we're going to calculate the slopes of each of these lines. So let's do the cheetah first. Now, remember, to calculate the slope, our slope calculation is rise divided by the run. So in order to find the rise of this, we're going to rise from the origin. Notice it starts at the origin and it rises up 100 and runs 4 seconds. That's how fast the cheetah runs. It runs 100 meters in 4 seconds. So our rise is 100 and our run is 4. And so calculating this, we've got 100 divided by 4, which is 25. And this is a very important part about our section and how we're differentiating slope and rate of change is that a rate of change must include units. In this case, the rise is measured by meters and the run is measured by seconds. So since we're taking the rise and dividing by the run, we're taking the meters and dividing it by the seconds. So notice we have our rate of change is 25 meters per second, which is its speed. So let's get the kangaroo. The kangaroo rises 100 and runs 5 seconds. It takes 5 seconds to run 100. So we've got our slope calculation, 100 divided by 5, which gives us 20. And it's the same units, meters per second. So the kangaroo, notice the number is smaller. And that makes sense that he runs slower than the cheetah. And the steepness of the line is not as steep as the cheetah's. This number is the steepness of the line. Lastly, let's do the human. And the human rises 100 and runs 9.6. He takes 9.6 seconds to run 100 meters. So let's calculate it. Rise divided by run. So we have 100 divided by 9.6, which gives us 10.4 meters per second. Okay, so after calculating this, we see these 3 different speeds. The speed, which is the rate of change, how fast the distance is changing with respect to time. We can see that these speeds relate to the slope of the line, and therefore our slope is the same as our rate of change. Our slope is the speed in this case, since we're talking about distance and time.